Hi everybody. So this is my second video on using the Moivre theorem to prove trigonometric identities. In the previous video, we looked at cos and sine of 5 theta. In this video, we're going to look at the cos of 6 theta and proving this is equal to this right-hand side. We covered the Moivre theorem and we discussed how we can simplify the I terms when they're raised to a power. And because we're looking at the cos of 6 theta, we're going to need I to the 6. And this will be I cubed squared. So negative I squared will give us negative 1. So through de Moivre's theorem then, if we replace this n with a 6, then we'll get cos to the 6 theta plus I sine 6 theta will equal cos plus I sine theta to the power of 6. So our approach will be to expand this out using the binomial expansion and then to equate the real parts. And you'll notice that on the right hand side there's no sine squared terms. So we'll use the identity that cos squared theta plus sine squared theta will equal 1. This will help us write sine squared in terms of cos squared. So we'll begin by expanding c plus is to the power of 6. Our first term will be c to the 6, and then 6 choice 1, c to the 5, and then if to the power of 1. 6 choice 2 will give us 15, c to the 4, is squared. 6 choice 3 will give us 20, c cubed, and is cubed. 6 choice 4 will give us 15, c squared, and is to the 4. And then we'll get 6, c if to the 5, and then if to the power of 6. And then we can replace the I squared, I cubed, I to the 4, and so on with each of these. So we'll get c to the 6 plus an I term, and then I squared is negative 1. So we'll get negative 15 c to the 4s squared. I cubed is negative I, so minus 20 I c cubed s cubed. I to the 4 is positive 1, so 15 c squared s to the 4. I to the 5 is positive I, so 6i cos f to the 5. And then I to the 6 is negative 1, so negative sine to the 6. And then you can see we've got the real parts and the imaginary parts. So we need to separate them from this. If I highlight the real parts, these are the terms without the I, and then the imaginary parts, these are the terms with the I. Then cos 6 theta plus I sine 6 theta will equal the real parts plus the 15 c squared s to the 4 minus the s to the 6. And then we'll factor out the I term from each of these imaginary parts. I'm just going to highlight the real parts in green. So we'll have this imaginary part, 6 cos to the 5 sine, minus the 20 cos cubed sine cubed, plus the 6 cos sine to the 5. But all we're concerned about here is this cos term, which is the real term. So we can ignore the imaginary parts. And then we can use cos squared plus sine squared to write each of these sine terms in terms of cos. So we'll get cos 6 theta will equal c to the 6 minus 15 c to the 4, and then s squared becomes 1 minus c squared plus 15 c squared, and s to the 4 becomes 1 minus c squared all squared, and s to the 6 becomes 1 minus c squared cubed. So if I just make some space, we know 1 minus c squared all squared will be 1 minus 2c squared plus c to the 4. And then 1 minus c squared cubed, using a binomial expansion, will be 1 plus 3 lots of negative c squared plus 3 lots of negative c squared squared, and then plus the negative c squared cubed. So this will give us 1 minus 3c squared plus 3c to the 4 minus c to the 6. We'll substitute this one into here and the cube one into here. So this will equal c to the 6 minus, expanding this out, 15c to the 4 plus 15c to the 6, and then 15c squared, 1 minus 2c squared plus c to the 4 minus negative c squared to the 6. We need to expand out each of these brackets. So we get 15c squared negative 30c to the 4 and 15c to the 6. And then expanding out this negative, and now we can collect the like terms. So we've got 1532 cos to the 6 theta. We've got negative 45, take away the 3, negative 48 cos to the 4. We've got 15 and the 3 c squared, so plus 18 cos squared theta, and the constant term of negative 1. And this is exactly what we were asked to show up here. Okay? Well, thank you very much for watching. I hope you found that helpful. If you did, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.